Hello everyone, welcome back to the SQL Server video series. My name is Debarchan and I work for the user education team in Microsoft for SQL Server integration services. Today I'm going to show you how we can take the advantage of a new SSIS transform component called Balanced Data Distributor to speed up package execution. This video assumes familiarity with basics of SSIS packages and data flow components like data flow source, data flow transform, and data flow destination. Balanced Data Distributor, or BDD, is a new SSIS transform component designed to take advantage of concurrent processing capability of modern CPUs. It does not have any configurable options, and it takes a single input and distributes the incoming rows to one or more outputs uniformly. It is to be noted that the use of the BDD component is beneficial in a data flow which has slow performing transforms within it. This transform takes one pipeline buffer worth of rows at a time and moves it to the next output in a round-robin fashion. It works synchronously. So, if one of the downstream transforms or destinations is ours, the rest of the pipeline will stall. This transform works best if all the outputs are connected to identical transforms and destinations. Our main use case scenario is with situations where the destination is slow in general and also where there is a room to take advantage of the parallelized inflow, for example the SQL parallel data warehousing appliances. So this essentially means it is intended to be used to store data in a single underlying target, for example a database table. BDD transformation component supports SQL Server 2008 and 2008 R2 as of now. This transform is available for a free download at the Microsoft download site. So with this, we move on to a small demo that I have here. So if you can see, I have three packages, the straight destination, problem, and solution BDD concept. So we'll start with the first one, the straight destination. So each of the packages have a single data flow in them, and if I go inside the data flow for the first package, I'll see there is a source and there is a destination. So it's a pretty simple package. So I'll go ahead and start the execution here, and we will see that the package starts moving the rows. So if we see the source component, we'll see that we are getting all the records from a table called test, and this table typically has about a million rows in it right now. So this straightforward package just pushes the data into this destination table. It's called test1. As we see, the execution is complete. We go ahead and check that this package took a little over 22 seconds to execute. So once this is done, we move on to our next package that is called the problem.dtsx, and as you can see, this as well contains a single data flow, but the change here is it contains a transform within it. So it will take some time to execute, so I'll just start the execution here, and it operates on the same set of source rows. So it's bringing in 1 million rows of data, and for this demo I do not have anything fancy inside the transform, so I have just put in a script component, and I edit the script, and I'm going to show you what the script contains of. So it basically has nothing but this single line of code where I have put in a wait for some milliseconds here so that the data flow halts in there. In a typical business scenario, we will have a transform component in its place. So this is a dummy component, so a real life transform component could be a sort component, a merge component, and whatnot. So if we see that each buffer of row comes into the transform. It does some processing. In this dummy it's only a wait, and then it's getting pushed to this destination table. So if we just have a look, the destination table is the same test1 and the source table is the same test. So basically we are operating on the same number of records. So as you can see, because of this transform, the package execution is slower than the previous run, and it's still in process of moving the rows from the source to the destination. So we will wait for a few seconds here and let it to complete. So this is like this transform component will be replaced by an actual component in a production or a real life scenario. The previous package that we just saw was merely a source pushing the data to a destination without any transform inside it. So as we can see, the source has almost finished pushing the entire 1 million rows to the transform. The transform is currently operating on the last set of buffer, and now the package execution is complete. So we will stop the execution, go to execution results, and see that compared to the 22 seconds it took last time, this time it took 2 minutes and 15 seconds to execute because of the transform in between. So now the solution to this problem is having a BDD component inside the transform. So we move on to our last package, that is the solution BDD concept. As usual, it has only one data flow task in it. We go inside the data flow, and here is the point of our interest. Okay, so as I mentioned, if we see its properties, there is nothing we can configure. So apart from the description and the name, there is no configurable property for this BDD component. And as you can see, let me start the execution as it will take a while to complete. As you can see, this BDD component has two outputs, and they are to two slow performing transforms. So if I go to their code, we will again see nothing but a spin weight added to each of those transforms. So here's the spin weight call that we have, and so as you can see that instead of one buffer being pushed to the transform each time as we saw in the last package, now a couple of buffers are getting processed simultaneously to both the outputs of this BDD component. So in a series of tests performed in our labs, we found that this transform scales well up to 5 outputs. As you can imagine, this offers best possibility of upward scaling, and as such, using 5 outputs may not be the most optimum in a typical production or real life scenario. So our suggestion is you should start with fixed load, increasing the outputs gradually, and experiment to eventually find the sweet spot. So as you can see, the outputs being distributed to two different paths. It has completed execution. Now if I stop the package and go to the execution results to check the execution time, and I see it has dropped down drastically to 1 minute 19 seconds. So it's actually about 1 minute of gain of performance that we have achieved using the BDD component. So you can imagine a real life scenario where the package will operate on maybe 10 to 20 millions of data with really slow performing transforms in it. So we can use the BDD component in between, and we can redirect the output to different paths just to process multiple buffers concurrently at the same time. So in this video, you learned how to leverage the balanced data distributor component to increase the throughput of a package that has really slow transformations in it. You also viewed a demonstration where we saw how the BDD component drastically reduced the execution time of a package having a slope of transform in it. I would like to thank and the user edu team entirely, and especially Srikanth for getting this video done. I hope that you will find this video of help and return for other SQL Server videos in this website. If you find it useful, please do not forget to rate it. Thanks. Bye.